Imagine a child lying in a hospital bed, doctors stumped for years, the silence of uncertainty filling the room. Now imagine that silence is broken not by a miracle, but by an algorithm connecting dots no human eye could see. That's exactly what happened last week at Boston Children's Hospital. Using OpenAI's new reasoning model, they cracked 18 cases of rare genetic diseases that had completely baffled medical experts. Today, we're diving deep into how this breakthrough is rewriting the rules of pediatric diagnostics and why it represents a massive leap forward for medicine as we know it. Last Thursday, a team at Boston Children's Hospital tackled 376 unresolved pediatric genetic cases. These weren't just minor glitches. These were children suffering from conditions so obscure that traditional diagnostic pathways had hit a dead end. By feeding the data into OpenAI's O3 reasoning model, the system didn't just look up symptoms in a textbook. It acted as a high-powered detective, cross-referencing patient histories with thousands of published medical papers and genetic variant databases simultaneously. The result was staggering. 18 new diagnoses were confirmed immediately. This wasn't a suggestion or a probability. It was a definitive identification of diseases that had previously been invisible to standard clinical review. The model generated specific hypotheses linking unique symptom clusters to rare genetic variants, effectively bridging the gap between confusing physical manifestations and their biological causes in record time. What makes this particular moment historic is how the AI actually processed the information. Unlike older diagnostic tools that might rely on simple pattern matching or keyword searches, the O3 model engages in deep reasoning. It constructs a narrative for each patient, weaving together genetic data, clinical symptoms, and emerging scientific literature into a cohesive story. For instance, if a child presents with a specific set of neurological issues combined with unusual metabolic markers, the AI doesn't just flag those as separate problems. It hypothesizes how they might be two sides of the same coin caused by a single underlying genetic mutation. This ability to synthesize disparate pieces of information into a unified theory is what allowed researchers to identify diagnoses that would have taken months or years for a human team to uncover manually. Now, let's be clear about the role here. This isn't about replacing doctors. It's about giving them superpowers. The workflow was designed as a partnership. The AI didn't make the final call in isolation. It presented its findings to the medical team at Boston Children's Hospital and Harvard, who then validated and confirmed the results. In this context, the human expert acts as the conductor of an orchestra where the instrument is now far more sophisticated than ever before. The doctors provided the clinical intuition and ethical judgment, while the AI handled the exhaustive data mining and complex logical deduction that can overwhelm even the sharpest minds. This collaboration ensures that the speed of discovery doesn't come at the cost of accuracy or empathy. The impact on families is profound and immediate. For parents waiting years for an answer to why their child is suffering, this technology offers a lifeline. Before this workflow existed, those 18 children might have remained in limbo, receiving only symptom management without ever knowing the root cause of their illness. Now, they receive a diagnosis that opens doors to targeted treatments, genetic counseling, and a sense of closure for the family unit. Beyond these specific cases, the implications ripple outward. If this model can resolve rare pediatric diseases with such precision, we are likely looking at a future where similar tools assist in diagnosing complex adult conditions, accelerating research into cures, and fundamentally changing how we approach medical mysteries globally. We've just witnessed a pivotal moment where artificial intelligence stepped onto the operating table of modern medicine to help save lives. From stumping doctors for years to providing definitive answers in days, this breakthrough at Boston Children's Hospital proves that when human expertise meets advanced reasoning models, the results are nothing short of revolutionary. If you found this deep dive into medical AI fascinating, hit that like button and subscribe for more stories on how technology is reshaping our world. Drop a comment below with your thoughts. Do you think this kind of integration should be standard in every hospital by next year? Let's discuss it together.